Hi. Good morning, everyone. My name is Lok Srinivasan. I'm an engineering director at Cisco. Today, I will go through the journey to an IPv6 only campus. Even though it is campus, whatever I'm going to discuss today or talk about today is going to be relevant to any network, be it service provider, data center, or any network of that sort. Right? So what we did at Cisco here is like, to give a brief summary, is like we picked a building in Cisco. It was a dual stack building, and we migrated that entire building into an IPv6 island and converted the entire set of users as well as like the network infrastructure to V6 only. That's the journey I'm going to talk about today. Before I get into the slides, I just had few questions while everyone is trying to assemble and so on. How many of you have a IPv4 or a dual stack network in your organization? Can I get a show up? Okay. Okay, that's probably around 40. I'm just estimating as such. And how many of you have a V6 only network in your organization? Well, that's good. They're like, okay, there are 4 is what I counted. So clearly, I think we have a long way to go for us to move into a V6 only organization. And that's one of the main reasons why we wanted to start this journey to migrate a building into a V6 only network. Right? So the agenda, briefly we'll go over the rationale for IPv6. This team will, this group of engineers will know this very well, but I'll briefly go through that. When you want to migrate a building from V4 to a V6 only building, there will be some roadblocks for successful adoption. We'll go through the roadblocks which we had encountered and what does it take for making it work. Then IPv6 readiness, especially even though it is like a first step towards IPv6 enablement, it's a leap forward for IT. And on top of it, like we'll go through some of the troubleshooting and the lessons learned which we had during this journey and the next steps. You with me so far? Okay. I'll take that as a yes. Okay. As you are aware of, we are running out of IPv4 addresses, and this is one of the main reasons we want to move into V6 adoption significantly across the globe. On top of this, we have few more reasons why we felt in our migration why we need V6 migration. The key thing I would actually say is operational simplicity. What does it mean? Currently, if you look at the applications at Cisco IT infrastructure, they are currently running in VMs, and we are in the process of migrating them into microservices and containers. And in this process, we expect approximately 40,000 VMs currently servicing the applications which we have at Cisco, and we are migrating them into microservices and containers, and that will need to be approximately 400,000 containers. That's the IT estimate of how many containers will be there. And if you want to do this migration, we need to go to V6. Right? I mean, it's impossible for us to assign an IPv4 address for any of the containers on an ongoing basis. Right? On top of this, if you look at any traffic which is going into the internet, that is going through at least 3 to 4 layers of NAT. So that is another thing which can be removed if you go into a V6 network. And adoption of IPv6 so far across many organizations had been mostly dual stack implementation. And going into single stack will eliminate the complexity a bit, because you have the routers and the switches. When you do dual stack, they are processing almost double the memory, CPU, as well as the TCAM space which is needed for operations. Right? So going into a single stack will make it operationally simple. That's the rationale for IPv6 migration. Right? And in this journey, what is going on is like there are web scale companies who are migrating DCs into V6, and the logical next step is to get campus into V6 as well. And that's one of the reasons why we pursued with IPv6 migration of the campus. Okay. More with it, what were the roadblocks we will encounter when we are going for an IPv6 adoption? The first and foremost thing is like an end user mindset. As an engineer, when I'm accessing, let's say, a lab, I will do an SSH into 172.62.34.45. I'm just picking a number. I'm like doing a telnet or an SSH into a host, and in an IPv6 migration, it's very hard for you to do the telnet using the IPv6 long address. It's going to be quite difficult, so you need to move into a host name. Applications, one other thing we noticed is like all the applications are not ready for migration into v6. Engineers are used to tight VNC, and tight VNC does not support v6 as an example. And during the migration, we also found that like there are spots in the network. I mean, it was actually a surprise for us when we realized that our labs were totally v4 only. Then we had to find out a workaround for us to get that going. Not just that, when you're trying to access the internet, not all the sites are v6 ready. As an example, bbc.com, at least 3 months back, they were still v4. I mean, I believe even today they are still v4. And devices wise, Android devices do not support DHCPv6, so we had to find a way to get them going with to enable v6 in there for Android devices as well. So how do we make it work? We had like 3-step process. One is like 3 different areas we had to focus on. One is the IT transition itself, then the network validation, then the end user perspective. So we have a 4-step process for migrating this entire campus into v6. First step was to examine the network. This means what do we have in the access? I will have the next slide which will go through the details of the topology. For the access, we decided to go for a 3850 switch or a 9300. And for the core, we went for a Cat6K. And for the wireless, we went for a 8540 and wave 1 and wave 2 APs. Not just that, we had to analyze the traffic in the building, which means we had to find out what is the user profile. There will be engineers, software engineers, software developers, test engineers. We have like project managers and program managers, product managers. Everyone uses different types of applications. So we need to understand and identify the different applications which were in the building. Next is we wanted to validate the apps if they are v6 ready. For this, we had, I mean most of the networks are, the network is already dual stack, our network was already dual stack. So what we did was, in order to validate if the applications are ready, instead of migrating the network to v6, we enabled a v6 only SSID so that the applications could be validated. In this process, we found that like a good number of applications were not v6 ready, and for that we had to enable NAT64 and DNS64 for them to work. And on top of it, like for Android devices, we had to enable Slack and RDNSs for them to work as well. And as a third step, what we did was we created a v6 only data path, which means we created a parallel network which was purely v6 and without any v4 enabled out there, and we migrated about 100 users into that network. What this helped on is to identify the pockets in the network which were v4 only, which were not compatible to the v6 network. Labs was an example for that. After we did this, the final step which we took was to migrate the entire building into v6. Right? This wasn't like an easier process as such, because we had to have war rooms to address any of the issues which came in on an ongoing basis. And I'll go through the challenges which we had in the war rooms and so on. Right? As I mentioned earlier, it's one step to IPv6, it's a leap for IT readiness. Right? This is the San Jose 23 building network. In here, you can see the access side. We had L2 all the way till like the distribution. 3850 4K is where the access, and 8540 is the wireless. And the distribution, that's where the IPv6 SVI is in there for termination of IPv6, and above that is the site gateway, which is V6 only. So any line here in this entire building is all, entire topology is all V6, and we had eBGP between the distribution and the site gateway. Beyond site gateway is where we had, like I said, like this is an island. So beyond site gateway is where we had like dual stack, and it connects to the corporate network. Right. We also improvised this recently. We put the latest and the greatest switches. I talked about 9300, 9400. We put it in the access, and in the core we added the 9500. Right. So what did we get into? What is that we accomplished at the end of the day, right? So we had 500 users in the building. Each one of them have like 2 devices at least, so that's about 1,000 devices. 3 floors, 6 wiring closets, 500 plus switch ports, and 120 APs and 40 plus applications. It was a 3-month phased approach, which we worked together with IT organization, 2 engineers from engineering together with 2 engineers in IT organization. It's a 3-month process for us to phased approach to get this migration completed. What did this involve? We had, sorry, the slides went away. So, sorry, too many clicks. Yeah. So in the building, we had a significant amount of applications, examples for VNC, remote desktop. I'm not going to go through each one of them, but I'll go through them briefly. Collab endpoints we had, which were running on PC, on laptops. We had like Cisco Spark, Jabber, WebEx, and the devices which were there in the network were like Mac, Windows, iPhones, Android, and enterprise services were like Cisco TV, AnyConnect, telepresence, proximity. Every one of them had a different set of challenge for us to get into a V6 only network. Right? And the management part was like SNMP, NetFlow, and the network protocols which we used were like NAT64 and DNS64 and Slack, which we had to enable for us to get into V6 migration. The slides are okay. In this transition, there were few critical things as such. It was not just the applications. It was also the end user perspective is what we had to look at. We had to build in user profiles. Some of them are, I mean, anyways, the slide is not showing up properly, but that's okay. We had engineers who are in the resident in the building, who belong to different projects, as I mentioned. And not only that, even after we did the migration, we had visitors who would come in from outside, and they would have some issues in their applications as well. So we had to have workshops and dry runs. The dry runs which we used primarily were in step 1 and 2 and 3 in the migration process, and the war rooms were something which we had in step 4 for the migration process. So where we were in July 2016 is we had enterprises, they had dual stack. In our network, we had like an IPv4 based management policy and network policy, and the data path was also v4. Where we are now, we have enterprise products which are IPv6 ready, and some of the enterprise organizations are migrating into single stack, including Cisco. And in our building out there in Building 23 in San Jose, we have an IPv6 only network where the network policy, management policy, as well as like the data path is purely v6. We also introduced something called an IPv6 solution testing. That's pretty much to ensure that like on an ongoing basis, we are IPv6 ready. So that's on the journey as such as like how it went in. Now we'll go a little bit more deep into the IT readiness perspective of IPv6 migration. Right. We wanted to keep the building network simple. If you remember the topology diagram out there, we had L2, and then we had routing, which was going on the site on the distribution. Then we had DHCPv6 enable, VSS for redundancy, and primarily for wireless. So this is an example of the VLAN configuration which we had. We had 5 VLANs in the entire building. One for wired data, wired voice, wireless data, and wireless voice, and also one for the APs. This is an example of a VLAN which was used on the switch for wireless data, which was mapping into an SSID called corp, the corporate SSID. And as you can see here, it says like no autoconfig. In our IT policy, we are not supposed to enable Slack. So by default, we had enabled DHCPv6, and we had to disable Slack in the network. However, in the building, we also had users who are using Android, so we had to take care of them. So we had to create a hidden SSID Android v6 with Slack enabled, and that's the second set of the configuration. So the next thing is like, how do you deal with IPv6 islands? So if you look at the small box, red box out there, and that's the building which we had converted. However, it is connecting to ENG labs. Labs were purely v4, and we had data centers which were like v4 and v6, and internet and campus core. I mean, everywhere is like dual stack. So it was super critical for us to enable NAT64 and DNS64 for the entire building to function. NAT64 and DNS64 was what was like holding it together. For this we used bind9 as a DNS server. So any query from the host will actually go to the bind9, then it gets connected to the corp, and you don't have to. So this was an add-on to the entire network together. You don't have to have a separate DNS server. Bind9 server had to be there as a in the middle to get the DNS queries, and that goes to the corp, right? And ASR1K was used as a NAT64, and this is the configuration which was like used on ASR1K. It's actually pretty straightforward. So coming into the applications, we had a significant amount of applications, approximately 40 plus applications running in the building, and some of them were in this building. So in this slide, you can actually see that like there are applications which are green, which means that like they were IPv6 ready. Yellow means they were not IPv6 ready, and later on we got a revision or a newer version of it, and we were able to get IPv6 enabled. And red means we were not ready for IPv6, and we had to use NAT64 or DNS64 for us to enable, get them working on the v6 network. I'll briefly go through the troubleshooting and the case studies and the lessons learned. So here, one of the key areas I wanted to highlight is like real experience is what matters. We had actually done quite a bit of design on the network, and and anticipated quite a bit of things as like what needs to be, what are the different applications, how does it work, and so on. But real experience is what counts, and real impact of the apps and services, we were able to understand it only when we enabled the network and when we got it up and running. Right. As an example, Nimbus Access. Here, it is not really technical. It is actually more behavioral. As I mentioned, IPv4 target host names where like whenever they are host names, it's not a problem at all, because DNS64 will actually do the translation and NAT64 together, first DNS64 or translating to the v4 address, and then NAT64 for it to go to the external world. That translation was easier, but it was more of behavioral. Like when engineers were trying to connect to the lab, they would connect to 172.16.32.1, and we had to have a mechanism for them to do the same thing in a v6 enabled network. So what we did was we had to create a script which will convert the IP addresses into domain names in a simpler fashion. So they will be very close. It will be like instead of a dot, they will use a dash, and they will be able to connect. These were the NAT64 and DNS64 issues we encountered. We were getting 4A responses which were incorrect. It means like someone, when we try to access logs.com, someone had coded, some sysadmin had coded in their DNS server that it's pointing to a wrong IPv6 address. So the workaround was we had to exclude the prefixes other than 2000/3 for making sure like these are working. And on top of it, like when you have a 4A query, if it returns a serve fail, it was causing a DNS64 synthesis failure. And for this, we had to artificially force the clients to go through NAT64 for them to get connectivity, right? Connect to the site, right? And few other things which we encountered. I mean, this is the thing I was talking about. The real experience is what counts. Sometimes it's like we can. We had quite a bit of surprises out there. VMware Fusion was another example. VMware Fusion on Mac did not work with an IPv6 network with NAT64 translation, and we had to, in this case, we had to change the Fusion VMware Fusion node to a bridge mode and to make it work. And Oracle VirtualBox was another issue. We did know when we went into the migration that like Android we have to enable Slack, but when we went into the deployment, we realized that like Oracle VirtualBox also had this dependency. So we had to connect those users to a Slack network as well. Android, I talked about it. We had to have Slack enabled, and we had to create a separate SSID which was hidden for us to get this going. Not just that, even some of the internal messagings we had for softphone as well as like Jabber, we had issues as well. So in IPv6 we did not enable port 8443, which was needed for softphones to be working, and we had to work with the development team to enable that. So this is one of the things which I had highlighted as yellow. Where we found that like during the deployment it was not there, and after we got a patch we got it working. Other issue we had was like Outlook on the Mac. You will connect to the network, you connect to v6, and you will notice that like you will not be able to download mails. And it's because like we need to have 15.3 or above on Outlook for you to work on a v6 only network. So these are all like some interesting challenges which we had as such, because it comes only through experience. And on top of it, like I said, like we also had the war rooms. The reason why we had to continue that for a little bit longer than 1 or 2 weeks after the migration is because visitors will come from outside of the building. We had to have like a big placard out there which actually says like it's a v6 only building, and if you have any issues, go to this war room, or like an email address, because like someone will come from outside. Cisco's internal Mac Outlook version at the time was 14.6, I think, and that was not compatible. So which means like anyone coming into the building will not be able to access emails. So it was kind of like a repetitive pattern out there. But the good thing is like we were able to get over it with war rooms, and we are now at a point wherein like we can say that like the building is functioning with v6 only. So what next? We are working with enterprise partners to enable more v6 only deployments. It's needed. It's super critical for us to go and deploy v6 across the board. And within our own organization, DC migration is important because like we have created an island, we have one island where we are able to work, but then like this doesn't scale because this is we need the entire ecosystem in the larger network to also be compatible. So we have a plan to migrate the DCs, and the DC migration will enable more and more buildings to be going into V6. And we had to change the development process as well. So we were at a point wherein like we were doing V4 first, and then we will do a catch up on V6, and that needs to change. So we have to develop V4 and V6 together, and that way we have a parity from the get-go when we want to go into V6 only deployments. And we are also working with a wide variety of application leaders in the industry for getting applications to be V6 ready as well. So Netnet, I think the key thing I wanted to bring to this theme is like V6 migration is doable, network migration is a part of it. The majority of the issues we faced in our V6 migration is primarily in the users and the applications. So network migration, you feel, I mean, like V6 is simple and it's easy. You have a CCIE and you will be able to bring it up and running. So that was like the easiest part. Getting the end user perception as well as the application is what was very challenging, and we felt like it's important for us to share this with the larger team and hope you would have got something out of this. More importantly, when you are doing a migration to a V6 only network later in the future, just remember that like it's not just the network, it's actually the users as well as the applications together. That's all I had.
Hi, my name is Lee Howard from Rotevia. Thank you very much. This is fantastic. I'm glad to have the field experience report. Were there any applications that you had to abandon because they wouldn't work with NAT 6.4 or V6 only?
Tight VNC.
I'm sorry?
Tight VNC. Tight VNC. We had to change it into real VNC.
Good.
So,
right. Yep.
So we had to give workarounds.
Yep.
Yeah.
And what's my other question? Go ahead while I.
Hi, I'm Michael Osman with Coinbase. Did you encounter any operational issues with the Androids being strictly on Slack?
So once we enabled an IPv6 only hidden SSID, then we didn't have any issues after that. So we were able to sail smoothly. So the issue was more of like we have a Cisco ID policy where we don't want to enable Slack by default. So that was the reason why we had to go to a lot of InfoSec approval and security compliance and so on. And finally, like we came into an agreement because we are jointly working with IT that we will keep it as a hidden SSID for the Android users. But once we enabled it, it was okay.
Mind if I ask a follow-up question? Why is the preference to go with the IPv6 versus Slack? Is it for auditing and logging?
I'm not the right person to answer this question, but more importantly, so it's more of like you will be able to identify the user much easier when you have a DHCPv6. In a Slack, I mean, you can have you can spoof your Mac and you can get your own IP. So that's one of the reasons why Cisco IT does not want to do it, right? I mean, hope that made sense.
Yeah, as it turns out, that was my other question.
Okay.
But I was surprised that you don't use .1x or network access control or something to do more thorough vetting of devices joining the network. But hey, you know, that's fine. It's your IT department. You get to decide that.
Yes, yes. So we didn't have .1x enabled at the time. So but that's true. We can actually enable it.
Hi, Hugo Slab at Demonware. Did you encounter any issues with NAT 6.4, DNS 6.4, and DNSSEC for the applications you were working with? Like, did you have to do like a break DNSSEC ES kind of thing, or were there any concerns?
So can you repeat again?
So were there issues where you encountered NAT 6.4, DNS 6.4 breaking DNSSEC that you had to, or with validating client resolvers, or did you not run into actual operational issues?
So there were a couple of examples I had given. Yeah. So those were the issues we had encountered. wherein like your DNS64 will will respond back with an IPv6 address which is not really a unicast IP address, and and that was the one issue we had. And with respect to NAT, we did not encounter much as such. Most of the issues we encountered was with like DNS64 translation, giving some address which is irrelevant.
But no DNSSEC specific things that there are like A's
no
only.
DNS site specific, yeah. At least in the enterprise side. So I can take one more question. There's like a few, or we are out of time, is it? All right. Thank you so much. Thanks for the opportunity.